Okay, we're going to start this exponential logarithmic by going back to grade 10. You ready to go back to grade 10? Okay, so here are some basic things. So what is 2 to the exponent 0? 2 to just 1. Anything to the 0 is 1, right? Remember that rule? 2 to the 1 is 2. So the rule would be anything to the 1 is itself. Okay, so then you should know these numbers. 2 squared, so 2 times 2 is 4. 2 times 2 times 2, 8. 2 times 2 times 2 times 2, 16. And 32. Can you keep going like that? What would be the next one? 64. Okay, then we had this rule with negative exponents. What do you do with negative exponents? You did this in grade 10. If it is a negative exponent, you move its location. So if it was on a top of a fraction, you would move it to a bottom. If it was on a bottom, you would move it to a top. So this would be 1 over 16. So this would be negative, so I'm going to move it to the bottom, which would be 1/6. Again, this is on a top, so I would move it to a bottom. And then it would be 1 over, and do you know what 3 times 3 times 3 would be? 27. Okay, then this is also something you learned in grade 10. The square root of 9 is also the same way of writing 9 to an exponent of 1/2. That is the same thing in math. Okay, which obviously would then equal 3. This is a cubed root, which is the same thing as writing a 1/3 exponent, which would be 3. And the 4th root is the same exponent as a 1/4. Okay, so negatives move it. Radicals are fraction exponents. Okay, you have to have that down pat, and these were grade 10 ideas. So somebody might be able to write this differently. If I ever give you this, do you understand that you could also write it as that? Because it was on the bottom, so I could move it to the top, but just change the positive negative, right? Okay, so this is what's going to happen with logarithmics, because you've never seen a logarithmic before. So 3 squared equals 9. That's how we've gone through life. That's what your brain does instantly. That's an exponential equation where we're inputting the exponent and then we're trying to get the result. Logarithmics are going to make us work backwards. So log 3/9 equals 2. So a logarithmic is you trying to get an exponent. Okay, so your brain doesn't usually think like that, right? Because you usually get what's the result of something. This time you have to think about what's the exponent in the situation. That's what we're going to do. Okay, so here's some logs. Let's figure them out. So the logarithmic equations here. So here's the format. Log base result equals, and then we have to get to the exponent. So the base, so here 3 is the base. We have to think of the exponent that made a result 27. So that's what I'm doing. What's that question mark going to have to be? 3. 3 cubed equals 27. Okay, so here we go. I'm following the format. The base is 16. We have to think of the exponent that has a result 4. Can anybody think of this one? It's a little bit tricky. 16 to a what would get you to 4? And I should tell you that you would never touch a calculator on this kind of stuff. Okay, go back here. What were some rules? Go back to the top. It's what I just taught you up there. $16 squared, nope, doesn't get me to 4, but you're kind of 1/2. 16 to the 1/2 is the same thing as doing what? Square root of 16. Okay? Okay, so now on this one, so the base, right here, the little baby base is 8.
Sorry for the interruption. We are just testing the system.
And we have to think of the exponent that is going to get us to 2. Anybody have an idea? 1/3, yeah. Because, what do I know? The cubed root of 8 is 2. Okay, so this one says the base is 8. And we have to think of the exponent that gets us to that. Well, my first impression is, well, I kind of know 8 squared is 64. Okay, so that is in my mind. And then also there's another thing that it looks like it's all of a sudden on the bottom. It's a fraction instead. So what would have done that? Negative would have moved it to the bottom location. Okay, the next one here, the little base is 9. We have to think of the exponent that would get us to 1/9. So again, that location moved. So what did that? A negative. And on the last one, the base is 6. We have to think of an exponent that would do that for us. What do you know? 0. Anything to a 0 makes 1, right? Okay, so those rules, you really have to have them always in the back of your mind. Okay, any kind of rooting is a fraction exponent. Okay, any kind of change, like flipping it to the bottom, that's going to be a negative exponent. Okay, let's do flipping pages until you get to this chart. Okay, so exponential form has a base, an exponent up top, and it would equal a result, right? That's how we've always functioned. Some kind of base to an exponent equals a result. So a log form would be the log of Remember your base, result, and then you now have to get the exponent. Thinking of that whole thing backwards. Okay, so I gave you an example here. This exponential, I moved it around into those positions. So I already did one for you. Okay, so here's an exponential. How would you write this as a log? So log, what's the base? 4. The result of it was 2 equals exponent a half. Okay, this one. So what's the base? We're going to go to exponential here. So the base is 2. What's the exponent? 7 equals the result. Okay, log. So the base of this was the 3. The result was 9 equals 2. Okay, and then the last one going to exponential. So the base was 2. 4 was the exponent. 16 was the result. Okay, so on this one, we're going to estimate the value of this log. Okay, so you are not allowed to whatsoever touch your calculator on these. Okay, so don't even think about it. Okay, so what's the base? 2 to some kind of exponent, and you got to get 40 out of it. Okay, you're not going to get 40, by the way. It's just going to estimate it, and you're going to need to go to 1 decimal place on these questions. Okay, so can anybody tell me anything about 2's that you do know? 2 to something equals something. Do you know some offhand? I think from the first page we did here, we had that written down, right? 2 to the 5th was 32. 2 times 2 times 2 times 2. And then we even went one further. 2 to the 6th, that was 64. Now, what can you already conclude about your exponent? Would we agree that it's going to have to be between 5 and 6 somewhere? So x approximately would be, and you have to go to 1 decimal place, 5 point, what do you want to do? It's just an estimate. 0.3, I like that, it's good. So approximately 5.3. That was, I know how to do the answer. I'm not going to tell you guys what I did. But that's what it is. So look at our estimate. That was good. Okay, next one. The base was 6. We have to think of the exponent that does that. Okay, well, I know 6 squared is 36. 6 cubed is 216. So what do I know about the exponent? I think it would be between 2 and 3. So 2 point. Which one do you feel like you're going to be closer to there? Should we be a little bit closer to the 2 or closer to the 3? Middle-ish? Oh. What are you thinking? Something like that? Okay. So there would be some wiggle room if you had guessed 2.5, 2.6, 2.7, probably all great guesses, okay? If you guessed probably 2.1, I would say you're a little bit too far onto the one side. Okay, something to note. Do you notice how here I put X and here I didn't? Okay, so if you had wrote me X equals, approximately equals on this one, you'd be wrong because there's no X. That'd be like me saying, hey, 5 times 4, what is it? And then you would be like, X equals 20. I'd be like, I don't know what you're talking about. There's no X, okay? So notice how here there was a variable X, here there wasn't. Okay, solving some equations. So here we go. This is the base result exponent, right? You got all your components down now? Base result exponent. Can you change it for me? Can you put it into exponential format? So it's in log format. Can you change it like we did at the top? So base exponent equals result. So 25 equals 4x plus 1 minus 1 Okay, now I just have to tell you this rule. I feel like it came up like 4 times on our provincial exam this year. Whatever's in this result position is never allowed to be negative. Big idea. So just like how it's a big idea you can't divide a number by 0, this is also just a big idea that your result position can never be negative. Okay, number 2. Go ahead. Move its format for me. Can you change it into an exponential form? Base exponent equals results. So that's what it would look like. Okay, big idea here. How do you solve an equation that looks like this? What's your first instinct gonna say to do? Were you thinking 0 equals? You have to have a 0 on one side. Okay, whenever you have multiple variables, x squareds and x's, you have to have a 0. And then I'm going to do some factoring strategies. So this is a simple trinomial. So 4 and 9. Okay, before I say that that's my answer, I have to verify that it didn't cause a negative in. I can't have negative, right? Can't have negative there. So what is, when you plug a -9 into this, is it still okay? Yeah, it's still okay. It's not that -9 is the problem. It's when I plug the -9 in, if that's negative. And then 4 squared plus 5 times 4, that's going to be positive as well. That's good. Okay, so I'm on page 8. Everybody found that last question at the bottom here. Okay, so this is a multiple choice test on your provincial exam. So first of all, I'm going to look at this, and I'm going to start to maneuver with that. So can you think about what's the base, exponent, result stuff? So this is the base, result, and exponent. Can you move that around? So base, exponent, result. I moved it around. Okay, I don't have a calculator, so you have to do this by hand. What is 2 times 2 times 2 times 2? 16. Okay, so now at least I know what x is. I know what x is now. So now I'm going to go to this one. So log 2 of 2, and I'm going to plug in 16 for the x, because I just solved for x. So now that's there. So now 2 times 16 is 32. Okay, so this is a log. So what is your brain doing? Your brain is trying to think of the exponent. So here's what your brain is doing. The base 2 with some kind of exponent has to make 32. That's what you're thinking about. So one of those answers is the exponent. Did you pick the 5? 2 to the 5th is 32. Okay? Okay, go to number 6. Okay, what's the following? So here's why I'm picking this question. This is a result, but this log expression didn't write me a little base. So that's awkward. Okay, so here's the trick. If they don't write a little base, it's assumed that the base is, does anybody know what the most common base used in math is? When we do measurements and stuff, it's all based on a factor of 10. Okay, so did you got to have that memorized? When there's no base, it's implied that the secret base is 10. Okay? So your calculator, to work with logs, you actually can only ever work with just the base 10. So does anybody know what my calculator should tell me with this? If the secret base is 10 and the result is 100, what should it be when I push equals? 2. Okay, if I do the log of 1,000, that should be a 3. Okay, so if the secret base is 10 and the result is 350, what's the exponent? Okay, so what do I know? I know 2 squared is 100, or not 2 squared. 10 squared is 100, and I know 10 cubed is 1,000. So what do you know about that? So I already know it's for sure not that, because 10 squared is 100. 10 cubed is out. So what do you think is the better guess? 2.5 or 2.8? What's 350 probably closer to? This one or this one? Probably this one. So I think I have to go a little bit lower because 2.8 is closer to the top end here. Okay, we'll do 7 together as well. What's the best estimate for this answer? Okay, so I take the first one. The base of it was 2. There's an exponent number. Okay, so I need you to figure out what's a good estimate of that exponent number. So I know 2 to the 5th is 32. And 2 to the 6th is 64. So what do you want to estimate that at? 5 point something? 5.2. Okay, then this says the base is 5. We have to think of the exponent. That one is an exact one, so you should know that one. 3, 5 cubed. So if I add those values together, which answer am I closest to? It just says. Looks like I'd be closest to 8, right? All right, flip. We're going to do number 9. Okay, determine the value of log 9, log 3, 27. Okay, so this looks complicated, so we just have to break it down. We have to do that part first. So can you think of the exponent number that makes that happen? So if there was a base 3, what kind of exponent would make that happen? 3. Okay, so this is 3. So now we have to do the log 9 of that 3. So what does this look like? The base is 9. We have to think of the exponent that makes that happen. So what is the exponent that makes that situation? 1/2. Square root of 9. Okay. And then the very last question, number 20. I'm going to do that one. Okay, this one is just different because you see ln instead of log. So ln is called the natural log, and in life, the natural log is that with a base of e. Okay, so e is a number in math, just like how if I say pi, you guys are like, oh, that's a number, 3.14, da da da. E also is a number, so you have it on your calculator. So there's my e button, so e to the 1. The number for e is 2.7-ish. So it gets used in life with like bacteria growth, population growth. So it's a natural exponential number in life. Okay, so I'm going to replace ln with log e. And then there was an e. Okay, so what does your brain do? What's the exponent that makes that happen? So if the base was e and the result was e, what's the exponent that made that happen? 1.